Let's study 9th standard ICSE chemistry chapter 7, the sums of gas laws. Now we are going to use the Concise textbook for the sums of gas laws because the Virav Dalal textbook has very easy sums. So comparatively, since Concise has more challenging sums, we would do that. Cancel the second sum. Now this is the in-text question of Boyle's law. To reduce your homework, I'm going to cancel the easy sums of the same types. Second sum is cancelled. The third sum, the hint is that this is all based on Boyle's law, which is P1 V1 is equal to P2 V2. In all these sums, temperature is constant. So here in this data, P1 and V1 is given, P2 is given, but V2 isn't given. So we have to find the value of X. So whenever you write a formula, you have to mention the law being used. Substitute the values, cross multiply and get the value of X. And there is a second part in this sum where we have to find the value of Y. So P3 is given, V3 is given, P4 is unknown, and V4 is given. By the way, we could have used P1, V1 also to find the value of Y. So here I'm substituting the value and we get the answer. Note that P3 and P4 should have the same units. Similarly, V3 and V4 should have the same units. If not, then conversion would be required. But this sum was very straightforward. Next, let's do the fifth sum. A vessel of capacity 600 centimeter cube. So that will be volume 1, V1. It's a good practice to write all the data first. That will make solving very easy. It contains hydrogen at the pressure of 330 centimeter of mercury. So that's P1. What will be the pressure, that means P2 is equal to question mark, when the vessel is connected to another vessel of 300 centimeter cube capacity? Now, don't think that V2 or the new volume is 300 centimeter cube. Actually, the two vessels have been connected together. That means the new volume is the addition of these two containers. That means new volume of V2 is actually 900 centimeter cube. Temperature is obviously assumed to be constant so that we can use Boyle's law here. So pressure, volume given, new volume is here and the new pressure is asked. So the two vessels perhaps connected with the help of a pipe. So if one is 600 and the other is 300, and the gas will obviously occupy both the vessels now, which is available to it. So the total volume of the gas is 900. So the new pressure would obviously be less than the original pressure. It's 220 centimeter of mercury. The unit of the final answer depends on the unit used in the question, which was centimeter of mercury. If they would have mentioned this in liters, our final answer would also have been in liters. And please don't just copy the answer. Actually start solving it so that you get the habit of calculations. Now the sixth sum, mark it as IMP. At constant temperature, a gas is at a pressure of 1080 millimeter of mercury. That's P1. If the volume is decreased by 40%, find the new pressure. That is P2 is asked. Now here V1 and V2 values aren't given. That's okay. At least a relationship between them is mentioned. The volume is decreased by 40%. That means the new volume is equal to the initial volume minus 40% of the initial volume. I like to write it simply as volume 2 is equal to 60% of volume 1. Because if it is decreased by 40%, that means 60% is the new volume. Note that this language is so important. This word by makes all the difference. If the sentence was, if the volume is decreased to 40%, that means the new volume is 40%. So we would have written V2 is equal to 40% of V1. So be very careful in sums where percentage is involved and ensure that you've understood it correctly. So now I have a relationship that V2 is actually 3/5 of V1. You could have assumed V1 is X also, but I don't want to introduce more variables unnecessarily. So now we use Boyle's law, we substitute all the values. Note how V1 and V1 got cancelled. That's why even if they have not given the values of volume, we can still solve it because we at least have the relationship between V1 and V2, which we have substituted here, from here. You could mention ... 1 and here from 1. And now 5 goes up, 3 goes down, cut and get the value of pressure and the sum is over. Next, the Charles law. This is another section of in-text questions based only on Charles law. Question number 1.1 and 1.3 is mere conversion. So we know how to convert Kelvin to degrees Celsius. Just subtract it. Subtract 273 from it. And degree Celsius to Kelvin, well, add 273 to it. Remember, 0 degrees Celsius is 273 Kelvin. And the lowest possible temperature, which actually can't be reached, is minus 273 degrees Celsius or 0 Kelvin. Now let's do the fourth sum. Charles' law means V1 upon T1 is equal to V2 upon T2. And here we are assuming that the pressure is constant. So calculate the volume of air expelled from a vessel which was initially containing 0.4 liters. So this is your V1, initial volume, at 250 Kelvin. So this is your T1, initial temperature. When it is heated to 27 degrees Celsius, so this will be your final temperature, or T2. So if V1 is given, T1 is given, T2 is given, obviously we have to find V2, or final volume. By the way, we always should convert degrees Celsius to Kelvin before we use Charles' law, otherwise we'll get a wrong answer. So we substitute the values. Note that the temperature is always in Kelvin. Volume could have any unit, since they give us the unit, the value in the unit of liters. So when we cross multiply, and please do that and calculate it in the rough work, I want to see the rough work also, we get the answer new volume as 0.48 liters. Now what's happening here is, initially the container was filled with the gas. It was totally filled with to the brim. The question is that if you heat it and increase the temperature, how much of the gas will be expelled? Now initially the volume of the gas was 0.4 liters. That means the volume of the container is 0.4 liters. And now the new volume is 0.48 liters. So definitely there is an excess gas here, because gases expand on heating. And the question was, what is the air expelled? So the sum isn't over yet. This air expelled will be the difference, which is 0.08 liters. Not only that, they said find the volume in centimeter cube. Now how do we convert liter to centimeter cube? Well, just multiply by 1000. So the answer is 80 centimeter cube. Remember, 1 liter is equal to 1000 milliliters. And that is actually equal to 1000 centimeter cube, because 1 ml is 1 cm cube as well. Now the sixth sum, that's an IMP sum. To what temperature must a gas at 300 Kelvin be cooled down? So initial temperature was 300, new temperature is asked, to reduce its volume to 1/3. They didn't mention by 1/3, but to 1/3. So again, the volume values haven't been given, but their relationship has been given, which we will use in the Charles' law. The new volume is 1/3 of V1. If in the question it was mentioned that the new volume is reduced by 1/3, then it would have been initial volume minus 1/3 of initial volume, which would be 2/3 of initial volume. Now we're going to substitute these values here. Instead of V2, I'm going to write 1/3 of V1, and V1 cancel. T1 value is given. So the only unknown variable is T2. T2 goes up, 300 goes up, 3 will be in denominator. Cross multiply and we get the answer as Kelvin. In the question, they have not mentioned any degree Celsius value. So we need not convert our answer into degrees Celsius. If they would have given the question in degrees Celsius, then we would have to convert our final temperature in degrees Celsius. Now the seventh one, prove that the volume of a gas at 273 degrees Celsius is twice its volume at 273 Kelvin at constant pressure. At constant pressure means it is Charles' law. Now they've given the initial temperature as 273 degrees Celsius, so we have to convert it into Kelvin. Final temperature is also given, which is 273 Kelvin, which actually would have been 0 degrees Celsius. Now the values of V1 and V2 is not given, but if we solve further and cross multiply, we realize that volume 1 is indeed twice volume 2, and that's what they had asked us to prove. Now let's do the exercise numericals. Let's cancel a few sums. Cancel question 1, 2, 3, then cancel 15th, 20th, 21, bravo, alpha is there, bravo cancelled, 24th is cancelled, 26th and even 28th is cancelled. Now in the in-text question of Charles' law, I said the sixth one is IMP, and now in the exercise the IMP sums are 7th, 17th, 22nd, yes, 3 IMP sums. Let's start with the fourth sum now. 800 centimeter cube of a gas is collected at 654 millimeter of pressure. At what pressure would the volume of the gas reduce by 40%? That means the new volume is 60% of the initial volume. So again, there is a by word out there. So be careful about this. So they have mentioned that temperature is constant. That's a big help, because now I know that I have to use Boyle's law. Now, initial volume is given. You may find V2, which would be 60% of 800 centimeter cube. But actually, we don't even need this value. If the relationship between V1 and V2 is given, then the actual values don't matter. So I'm not going to use it, because I have the relationship that V2 is 3/5 of V1 because it is 40% less, or I can say it is 60% of the initial volume. So these values can be substituted here. Yeah, pressure's value has to be substituted as well. V1 and V1 gone, which is actually 800. And now the only unknown variable is P2, and we get the answer of pressure 2. That is new pressure. Next, the seventh one. 561 dm cube. By the way, 1 dm cube is 1 liter. Of a gas at STP, standard temperature is 273 Kelvin, and standard pressure is 1 atm or 760 millimeter of mercury. It is filled in a 248 dm cube container. That means volume has changed. So please write the data, V1, V2. Temperature is constant. Again, great. So that's Boyle's law. Calculate the percentage change in pressure. Now, we know that since they mentioned STP, the initial pressure was 1 atm. But I don't need to use that value, although you can do that as well. They just want the percentage change. So let's calculate that. First of all, the Boyle's law. P1, P2 values are unknown. P1 you can use 760 millimeter or 1 atm. That's fine, but I'm not going to use it. V1 value is given, V2 value is given. So I find the relationship between P2 and P1. It seems that P2 is actually 0.75 of P1, or say 75% of P1. That means pressure has decreased. So how do we calculate the percentage change in anything? This is a usual math equation. That's a percentage change is always the difference upon the original value. Remember, the denominator has to be the original value into 100%. And the difference between P1 and P2, which is actually 3/4 of P1 or 75% of P1, comes up to 1/4 of P1. You could have used X variable also here, or decimal values is also fine. But you can see here, just by looking at this, that there is a decrease of 25%. So you should know this answer even without solving all this. But solving, you have to show. And you can see that P2 is smaller than P1. So you have to mention here decrease. Because change in pressure, we used initial minus final, not final minus initial, so that we get a positive value. So if the final temperature was greater than the initial pressure, then we would have written here increase. Next, let's look at the ninth sum. A gas at 240 Kelvin is heated to 127 degrees Celsius. That means T1 and T2 are given. Find the percentage change in volume. So again, pressure is constant. So we'll use which law here? The Charles law. Degree Celsius has to be converted to Kelvin first of all. Substitute the values. We don't have the values of V1 and V2, but that's okay, because we just have to find the percentage change. And I got the relationship between them. The final value is a little bigger than the initial volume, 5/3. So find the change in volume, which is the difference between the two, and always bigger number minus smaller number, of course. And percentage change is always the change in volume. There is a difference upon initial, always upon original volume, into 100%, which comes up to 66.67%. Next, the 11th sum. A given mass of a gas occupies 143 centimeter cube at 27 degrees Celsius at this much pressure. Okay, so they've given the volume, they've given the temperature, and they've given the pressure. Next, what will be its volume? So V2 is asked, second temperature is given, and second pressure is given. So here all three variables are involved. So here we will not use Boyle's law or Charles' law, we will use the gas equation. That is P1 V1 upon T1 is equal to P2 V2 upon T2. Make sure that the degree Celsius is converted to Kelvin first. Make sure that the unit of pressure P1 and P2, the units are same. So the only unknown variable is V2. Cross multiply, solve it, show the working, and get this answer. And how will we know what unit to write here? Well, whatever was the unit of V1 given in the question, that's the unit to use here. Next, the 13th question. Calculate the final volume of a gas, X, if the original pressure at STP is doubled and its temperature is increased 3 times. What is interesting in this sum is that no values have been given directly. But that's okay because they have not asked us to find the final volume value. We can simply give a comparative answer for that. Interestingly, they said that the initial temperature and pressure were standard values. So you can use those numbers. Standard temperature is 273 Kelvin and standard pressure is 180 m or even 760 millimeter of mercury. You can use either value. And then you can say that the new pressure is double of that, that means 280 m. And the new temperature is triple of that, that is 273 into 3 Kelvin. And use those values. And then find the relationship between V1 and V2. But I'm not going to use any of the values. First of all, the gas equation. Now the new pressure is twice the initial pressure. The new temperature is thrice the initial temperature. So pressure is gone, temperature is gone, so the values didn't matter anyway. And I got the relationship between V2 and V1. Clearly I can see that there is a 50% increase in the volume. The volume becomes 1.5 times the original volume. Don't say that the volume increased by 1.5 times. It becomes 1.5 times. Now mark the 17th sum as IMP. It is found on heating a gas, its volume increases by 50%. Increases by 50%. That means V2 is equal to V1 plus 50% of V1. Or you can simply say that V2 is 150% of V1. Pressure decreases to 60% of its original value. Not by 60%, to 60%. That means P2 is 60% of P1. So we get the relationship between V2 and V1 and the relationship between P2 and P1. Temperature 1 is given minus 15 degrees Celsius converted to Kelvin scale. So the only thing left to be found out is the final temperature. So we will use the gas equation, of course. Substitute all the values. P1 gone, V1 gone. T2 comes up, 258 goes up. 258 into 3/15 into 3/2. Please do all the calculations and get this answer. If you don't get this answer, you made some silly mistake, do it again. That's how we become perfect with calculations and avoid silly mistakes in exams. Don't leave the answer in Kelvin here because in the question they had given the temperature in degrees Celsius. So in the answer also we'll have to convert it into degrees Celsius by subtracting by 273. Next, the 21st sum. A given amount of gas A is contained in a chamber of constant volume. When this chamber is immersed in a bath of melting ice, what is the temperature of that? 273 Kelvin. So that's the temperature given. And the pressure is also given. Note constant volume. Question is, what is the new temperature, T2, when this is the new pressure? Now this sum is interesting because here volume is constant, which is neither the case in Boyle's law nor in Charles' law. So we'll have to use a gas equation. Pressure 1 was given as 100 and pressure 2 was given as 10. The volume is constant, so it disappears. Temperature 1 was of melting ice, which is 273 Kelvin, and the new temperature is asked, which is 27.3 Kelvin. Now the 22nd sum is IMP. The gas is in a tank whose volume is given. It is to be filled in cylinders, each cylinder having 10 liters capacity. Now ideally you would think that 10,000 liters into 10 liter cylinders, that means we need 1,000 cylinders. But it's a gas. Its volume changes with change in temperature and pressure. In the tank, that is initially, the pressure was this and the temperature was this. This turns out to be 270 Kelvin. But in the cylinders, the pressure has become half. It's just 400. The temperature, interestingly, is still the same, 270 Kelvin. Even this was 270 Kelvin. So find the number of cylinders. First of all, let's find the new volume when the pressure is halved. So for that, we'll use the gas equation. The old pressure and the new pressure. The old volume, original volume in the tank, and the new volume. And interestingly, the temperature is same. So we could have used Boyle's law also. That's fine. So this gets cancelled, and on solving we get the new volume to be 20,000 liters. So the 10,000 liters gas has now become 20,000 liters gas because the pressure was halved. And now this 20,000 liters of gas at a lower pressure have to be filled in all these cylinders, each having 10 liters capacity. So now tell me how many cylinders will be required. Well, number of cylinders will be total volume upon volume per cylinder. So the answer is 2,000 cylinders. Finally, the 25th sum. We've got two gases, nitrogen and oxygen. This is 1.2 liters and this is 1.25 liters. They've asked who has a greater volume at STP. If we ignore all the other information, you may say directly that oxygen has greater volume. But that will be an unfair comparison. Because oxygen is at STP, which is at 0 degrees Celsius and 760 millimeter mercury. And nitrogen is at a different temperature and pressure compared to oxygen. So comparing them like this is not fair. We'll have to convert the nitrogen's volume at STP. So let's do that first. We'll use the gas equation. Nitrogen's original pressure is 748 and original volume was 1.2 liters and original temperature was 298. At STP, standard temperature and pressure, the new pressure is 760. The new temperature is 273 and we have to find the new volume of nitrogen at STP, which turns up to be 1.08 liters. Now we can compare this with oxygen. At STP, nitrogen's volume is just 1.08 liters and oxygen's volume at STP is 1.25 liters. So now we are confident that the answer is B. So write this, answer B. That means oxygen indeed has a greater volume, which we can confirm only after converting the volume of nitrogen in STP, because we didn't know whether it will become more than 1.2 or less than 1.2.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.